All right. Welcome, everyone. We're going to talk about absolute value inequalities today. And so let's just look at some inequalities. When it comes to inequalities, it's things that are not equal. That's what inequalities mean. And so we have this. The absolute value needs to be greater than or equal to 7. So if the absolute value, my thing's unplugged here. One of these cords is going to be it. Here we go. We got to figure it out now. If the absolute value is greater than or equal to 7, okay, well, that means that any value from here on should work, right? 8 should work, 9 should work, 10 should work, 11 should work, and 7 should work as well because they were allowed to be equal to 7. Also, 7.5 should work, 8.5 should work, 9.5 should work, right? Every single thing starting at 7 and to the right of 7 is included. Okay, now, because we have the absolute value, that's not the only numbers that will work, right? We can also pick a number like -9. If we plug in -9 here, it will turn into a +9, and then it will be greater than 7. Okay, and of course, same with -8, same with -7, that would be equal to, same with -10, same with -9.5, -8.5, -7.5. And so we end up with a graph that looks like this. We end up with a graph where you have two regions that work, and just like before, two regions coming from two different answers. We're going to solve this very similarly, okay? Now, the way that this is coming from is we're going to start with here. We're going to split it up. We're going to have one where everything is the same, and on the other side, we're going to have one where everything on the outside gets changed, which is the exact same thing we had yesterday. So it's going to be x, which does not change because that was on the inside. It's going to be -7, which does change because that was on the outside. But here's the first big thing today. We're going to have to flip this sign around because it is on the outside and it needs to change as well. So you need to do kind of like a double flip, a double front flip. Maybe you need to do a flip-flop, which is what some people like to call it, whatever. We need to change the inequality sign and we need to change the positive or negative sign. We need to change both. And that's where both these things come from. Now, unfortunately, I have backwards colored them, right? This one is saying x is greater than 7. So that's this one over here. And then, of course, this one is saying x has to be less than or equal to -7. So that's that one. But that's how we do it. So if we do the same thing with this question and we split it up, we have one where everything is the same. We have one where we do a double flip the sign around, flip the positive negative signs around. Now, these are already simplified, so we don't need to do anything. Now, graphing these two, okay, x needs to be less than or equal to +4. So here's my +4. I need to be less than that. But if I look at this one, okay, I need to be greater than or equal to -4. So I need to be greater than to -4. Right, so basically you have these two answers which look very similar, except for instead of an equal sign, they have an inequality. And then you need to graph them on here. There will always be two. And these are your two options, okay? They're going opposite directions of each other, or they're going towards each other, okay? You can never have an answer where that looks like this. That's wrong, okay? You'll never see a question like that when it comes to absolute values. Our only two options are they're going completely opposite, like this, or they're going completely towards you. Now, if it's graphed like this, we wouldn't really write it like this. We would write it like this. Right? We would just say that they run into each other and they stop. Okay, so the black is really more along the lines of how things would really look. We'll come back to interval notation. What do you mean it wouldn't work?
So
Right. So up here, this looks perfect. Down here, these two arrows would basically like connect to each other, and it would just form a line that looks like this. You see what I'm saying? It's basically saying all the numbers in between are good, all the numbers out here are bad. So we just use a solid line like that. Okay, let's see it happen. So we're going to knock out a few of these questions pretty quickly. I'm going to be moving pretty fast because it's lots of Algebra 1. It's all stuff we already know how to do. So we need two equations. A agrees. What's the first easy equation? Everything's the exact same.
So x plus 6 greater than 7?
Yep.
X plus 6 minus 7. Less than 7.
X plus 6, negative 7. What about the sign? Less than. Right. So that's a flip and that's a flip. You got to have both. Okay, make sure you have both. That's like the only new thing, really, for the whole day today. So then we need to subtract. So this one we're not done yet. We need to subtract 6. That would be 1. For this one, we need to subtract 6. That would be negative 13. Did that all out of order. So we go to 1, which is right here. We put a circle. We go to negative 13, which is right here. We put a circle. Now, is this going to be colored on the inside or on the outside? So we know that x needs to be greater than 1 and x needs to be less than negative 13. So that means it needs to be greater than 1, less than negative 13. Another way to do this, a lot of times people have this kind of strategy in mind. They say, oh, if we turn this greater than sign into a little arrow, that will tell us which direction the arrow points, you know? And if we turn this into an arrow, that'll tell us which direction the arrow points. The only problem is here, right now, it looks like they're going towards each other, right? So you have to make sure you know that this is right here. And then that arrow is going that direction. And this is right here. And that arrow is going that direction. So this is correct. But these two things happen to be kind of in reverse order. What's up, Abe? So really good question, right? We have these circles. You remember doing the colored in circle, the open circle type stuff. That is important here. Okay, so we need to remember something that I'm not going to write on every question, but closed in circles are coming from any equal to included inequality. Okay, open circles if we have no equal to. So open circles on this question. But again, that's all old news. Any questions here? We good? Okay, number 2, moving very fast again. Okay, I need two equations. One of them is exactly the same. One of them is that double flip-flop. Okay, so I'm going exactly the same. I'm going double. Talking and writing at the same time is a struggle today, I guess. Double flip-flop. Flip the signs and flip the signs. So now I need to solve it. I'm going to add 3. 22. I'm going to divide by 2. V less than 11. Over here, I need to add 3. That's going to be negative 16. Then I need to divide by 2. All right, open circles, closed circles. What do you think, Aiden? What do you say?
So it's a less than, so it's going to get open circle.
I agree 100%. That 11 is in between here somewhere. Rachel, you think colored in between or colored on the outside? In between. I agree 100%. Yeah. We're trying to be less than 11, but greater than negative 8. And so we need both those things to be true. We need to be less than 11 and greater than negative 8. Again, the way that these arrows point is it's saying negative 8 is pointing this way. So here's negative 8. It should be pointing that way. It's saying 11 is pointing this way. Here's 11 pointing that way. So you can use these arrows, but you have to be careful. You know, these are kind of not necessarily in low to high order like this number line is. So you need to be a little careful. It looks like they're going out, but actually it's in this order. Okay, nice job. Let's see a question that spices it up a bit. Let's go down to number 7, or maybe on the back. I'm not sure whether it's on the back. Sounds like it's on the back. Now, number 7 is introducing, of course, you need to isolate your absolute value just like yesterday, right? So we need to go ahead and get rid of this minus 10 or negative 10. How are we getting rid of this negative 10? Dividing by negative 10, of course. Excellent job. Now, when we do this and we divide by negative 10, there's something else sneaky that's going on. What? It would become a positive 6. I agree. So that's good. But there's something else going on. Yep. You're exactly right. So inequalities, remember we have this rule, okay? If we multiply or divide by a negative, you have to flip the inequality. Okay, so right here, it was a less than dividing by a negative. We had to flip it, okay? Anytime ever. Some questions we might have to flip it and then flip it back and then flip it again and then split it up, which will require us to flip it again, okay? Flipping is, we're going to have to do it. I'm going to have to get two equations now. One of them, everything is the same. And you're absolutely right. We're going to have to flip it back to how it was before over here, right? I mean, that's fine. That's how it goes. We're just following the rules. Make sure you're flipping both. That's the only new thing today, really. Okay? We need to solve it. Add 1. That would be 7. Then divide by 2. Didn't make a mistake here, right? 7 halves. Add 1. Divide by 2. Okay, so one thing we need to do on a multiple choice test, this is really easy, right? Because we don't have to put the dots down. Sometimes students get nervous and like 7.5. It's not 7.5. This is 7 halves. So it's not over here. This is 7 halves of a pizza, okay? One way you can do this is you can count by halves. I don't see a lot of students do this, but you can say kind of like 1 half, 2 half, 3 half, 4 half, 5 half, 6 half, 7 halves, right? That's one way to do it. I don't anticipate a lot of students doing that, but you could do it that way. The way I like to do it is say 7 does not divide by 2. What's a number close to 7 that does divide by 2? 6. Okay, what's 6 divided by 2? 3. So it's around 3, but the 6 over 2 is a little bit smaller than I wanted, right? But it's also not 8 over 2, which would be 4, right? So you can kind of think about this top number, change it up a little bit, and that'll help you hone in. So yeah, 7 halves is right here. 7 halves is 3.5. Now, open circles, closed circles, what do you think? Closed. I agree 100%. And what about negative 5 halves? What number is that? 4 is close, right? Right, negative 4, right? That's close to 5, and so that would be 2. So this is near where we want to be. It should be negative 2.5. Yeah, I mean, you can do it like that for sure. If you know how to cut numbers in half, you're right. That works. It's a little trickier when you have like 19.5. But with these numbers, it's pretty easy, yeah? Okay, and we need closed circles. And now we need to decide, are we, arrows pointing together or arrows pointing outside of each other? I'm seeing that this direction of 7.5, oh my God, of 7 halves, made that mistake twice, So it should be over here. Then I'm looking in this direction of -5/2. So I'm going that direction. They should be going out. Okay, so this is super important to remember to flip your sign. That's super important. And there's nothing else really that's going on. Okay, if we look at a question like number 10, we need to remember to move the 1 and then move the -4. But also when we divide by -4, we're gonna have to flip the sign. But it's all the same stuff. The one that I want to do, bless it. The one that I want to do is either 8 or 9. Which one do you want to do? Okay, 9. So we're doing 9. We need to get everything by itself. What are we moving first? The 6 or the 7? The 7, I agree. 7's got to go. How do we move the 6? Divide by 6, I agree. Okay, we're getting this far. This looks not too bad. So now, we need to split it out. 1 needs to be exactly the same. 1 needs to be the opposite. So it would be -5 and should be less than -5. Everybody cool with those two? Okay, now, how do we get the n by itself? Divide by -5, right? And when you divide by -5, what do you have to do? You got to switch the signs. Anytime you divide by a negative, we're dividing by a negative, so we need to flip that over. Okay? We had to change this because we divided by a negative. Okay? What about on the other side? We need to divide by -5 again. That means it needs to switch as well. And of course, that side is just going to be a positive one. Okay, open circles, closed circles. Open, I agree. And together or away from each other? Away from each other. Yep. Okay, that is 90% of what we're doing today. Now, there's one other thing. As you can see underneath here, we have interval notation. Okay, now, interval notation is another way to write what is on the graph, except for you're going to be writing it using intervals. Okay, now the way you want to think about intervals is intervals are from where you start to where you finish. Okay, so let's start with number 2. Okay. Yeah, that's fine. So where is the interval where we find all the true answers? We find all the true answers right here. And so writing that down, our interval notation is going to say basically from what number until what number. So from what until what? So that's part of what we need to do. Now the next part of the interval notation is we need a comma between the numbers. And then we're going to need brackets on the outside of this interval. Okay, so this is your interval notation. It has to be written like that. And this is the same thing as the graph. It's just written without a graph. And the reason that we have the interval notation is because if you're a famous mathematician and you're typing in a computer, you don't want to have to draw this graph every time. You just want to be able to do bracket, -4, comma 4, bracket. What's up?
What do you do if it's facing away?
What do you do if it's facing away from each other? Right, this is very easy. A little tricky here, right? Because if we do -7, +7, our answers are not from -7 until 7. These answers do not work. This is all the bad stuff. So we need a different strategy, right? From until. What is the first answer that starts working on this side? Nope. What about -8? That works.
No, but -7 including. So what's the first answer
Right, and we're moving left to right, small numbers to big numbers. What's the smallest number that you could plug in right here and get to work? Could you plug in negative 10 in it? Would it work? Could you plug in negative 100? Would it work? Could you plug in negative 1,000? Would it work? Million, billion, trillion, gazillion, gajillion, million, trillion, billion, trillion. So, what is the smallest number that would work? Negative infinity. Our first infinity we've seen this year. And what is the highest number that will work? Nope. 7. We can't go from negative infinity until positive infinity because what about 0? That doesn't work, right? We can't say that. We need to stop at negative 7. That will tell us from negative infinity until negative 7. That's our interval. Okay? So we're always going left to right. Yeah. Okay, so we need a comma in between. But here's something that's a little tricky. Okay? We're only using brackets because we include the number. Basically because we have closed circles. Okay? So we do include negative 7, but you are never going to put a bracket on negative infinity. It's always going to use a parentheses. Because you can't technically include negative infinity. You can't say it's not a real number. You know? Right? What about negative infinity plus 1? What about negative infinity minus 1? You know what I'm saying? So we always are going to put parentheses on infinities. Now, that handles this side. We're going to need another interval for this side. So, again, we're going low to high. What is the lowest number? Where do we start? From, this time it's from 7. And what's the highest number? What bracket or parentheses over here? Bracket or parentheses over here? Parentheses. Now, this seems super complicated, okay? Parentheses, negative infinity, comma, negative 7, bracket, 7, comma, positive infinity. It seems like, wow, this is crazy. Every time that your arrows go in opposite directions, it looks exactly like this, okay? So it's one of those things where the first time you see it, it seems wild. But if you actually do like 3 of these questions in a row, it becomes pretty easy. So let's go back and let's do all of our interval notations. So let's look at this one. What's the first negative number that we include? What's the lowest number that works? You know, yeah. What's the absolute lowest number, right? Does negative 100 work? Negative infinity, right? What is the highest number that works? Basically, what number is this? Like, what number did we pick right here? We picked this. It's negative 13. So, negative 13. Okay? We always need a parentheses on the infinity. But for this question, is negative 13 included? No, we're not allowed to be negative 13. So we need parentheses over here too. So basically, if you have a colored in circle, okay, that means brackets. If you have an open circle, that means parentheses. But infinities are always parentheses, okay? You can never put a bracket on an infinity. Yeah, it kind of makes a little circle. You're absolutely right. Okay, now let's do this right portion over here. What is the lowest number that works? 1. No, infinity is a pretty high number. 1 is the lowest number, starting at 1, from 1 until infinity. Parentheses, parentheses with a comma in the middle. Okay, there you go. There's our interval notation. Now let's go do number 2. This one should be considerably easier. We don't have any infinities, right? We're stuck between those two numbers. So from what number? From negative 8 until what number? No. 11, right? Comma in the middle, brackets or parentheses? Parentheses. Right, because we got open circles mean parentheses. Okay? Let's go down. Let's do number 7. They're going in opposite directions now. That means we're going to have the infinities. Okay? So what is the absolute lowest number that would work? Negative infinity. Like I said, it's not that crazy. It's always negative infinity first. And you know, we already know it's a parentheses because it's always a parentheses. Now, what number does this interval stop? It goes negative infinity until negative 2.5. And I'm going to use fractions here. Negative 5 halves. Parentheses or brackets? Should be brackets. Okay. Now let's do the other one. Starting at what number? Starting right here at 7 halves. Going until infinity. Parentheses. Excellent, excellent. And last one, and then we're all done. Okay. Starting where? Negative infinity. Until when? Right? Parentheses. We're going to have all parentheses here. Starting where? 1 until infinity. Okay. Again, it looks crazy, but you do 3 of them in a row, and you're like, wait a second. You just pretty much put infinities on there, and it's not too bad. Okay. Now, the real kind of life hack here, okay, to give you guys a little life hack, I'm going to do number 5 super, super fast. Maybe skip some of the work. I'm going to multiply by 4. That would be q minus 1 greater than or equal to 8. I'm going to split it up into 2 parts. I'm going to get q minus 1 greater than or equal to 8. Then I'm going to get q minus 1, flip it, set up like that. I'm going to add 1, q greater than or equal to 9. I'm going to add 1, q less than or equal to negative 7. I'm going to go ahead and grab negative 7 with a colored in dot. I'm going to go ahead and grab 9, which is right here, with a colored in dot. I need to be greater than 9. I need to be less than negative 7. Okay, now, if I want to do the interval notation, really the life hack here is take this number, which is negative 7, the small one, put it over there, then take the big one and put it over here. Now, if it was between these two, I would put brackets like this and be done. Okay, if, like in this case, it's not between these two, it's on the outsides, I would put negative infinity and positive infinity. Right, but those two numbers, there are always going to be those middle 2 numbers. Now I just put the brackets like this. So anyways, that's one way you can think of it. That's one way you can maybe get a little faster. But all that being said, that is solving absolute value inequalities. Nice job.